Ladies and gentlemen, welcome back to astronomy. Today we're going to start our first actual online delivered lesson covering the topics of the sun and the moon. So if you would open up your interactive notebooks, we'll do a quick review of the pages that have gotten us up to this point, okay? And then as we press forward through those pages up to the beginning of chapter 1, what we do in this video will be pages 6 and 7. This is the start of chapter 1, our solar system. So without any further delays, let's go ahead and get started. Take a look at what you've got in page 2 and 3. I'm going to put my picture off to the side here. Page 2, we covered the distances in measuring the cosmos. We're going to use this term AU quite a bit, astronomical unit. The AU is used in every instance of objects defining their distances inside the solar system. Beyond the solar system, it's like measuring how many millimeters is it to get from here to a different country. It's ridiculous. So AUs, that works locally in our own solar system. Beyond that, we're using light years and parsecs and other huge measuring units. But inside the solar system, AUs, please keep that in mind as we go through. You'll hear that a lot, and you'll be adding it to your own notebook, some information about it. So that's page 2. Make sure you've got page 2 ready to go. Page number 3, it looks like this with an introduction and a list of objects that you had put labeled inside our solar system, beyond our solar system, so we can delineate, man, what's nearby and what's truly distant. And we can only glimpse them with our very best technology. So that's page 2, and that's page 3. Page 4 is your list of sources. You're going to refer to this page often as you build the rest of your book. So page 4 is where you looked website by website on this list right here, these 5 key websites, reliable, trustworthy sources, so that you know where can I look up information about certain things in different pages. What websites should I go to that I can get good information for as I build my book of astronomy? Okay. As a reminder, every page needs sources. Everywhere that you put down facts that you did not already know, cite those sources on the bottom of every page you do that. Okay. Also, Wikipedia, not a valid source. Google, not a valid source. Okay, so use these reliable sources: NASA, ESA, space.com, theplanets.org, and space-facts, an excellent resource. All these 5 trustworthy. You can use them for your whole book. Page 5 is your divider page that you added in when you first set up the interactive notebook, your INB. And now it's time for us to dive in and talk about the sun and the moon. Here we go. We'll begin with the sun. Look at it. It's glowing. It's powerful. It is pulsing with energy. And down in the core of the sun, nuclear fusion, something we've been unable to actually duplicate. Cold fusion, which the sun does with ease because it's hot, it's got tremendous pressure, and because of that reaction, that fusion reaction that takes one little hydrogen and another little hydrogen and takes them and forces them together, and boom, they make helium, right? Now we have helium, and it releases a tremendous amount of energy as we take one small particle, hydrogen, and another one and fuse them together, fusion, to create helium within the sun. So in a way, it's cranking out this fusion reaction, taking hydrogen, turning it into helium by the millions of tons every second of every day for the next 4.5 or 5 billion years, at which point things begin to change. We'll get more into that change in chapter 3, light and dark. But for now, let's focus on what we do know about the sun. Take a look at the glow in the animation. You see the corona floating around it? That is the glow of the sun, the energy that it spits out into space. Sometimes it's solar prominences, sometimes solar flares, sometimes huge loops form on the top of the sun, driven and twisted into a frenzy by strong magnetism. The corona, coincidentally, happens to be where COVID-19, the coronavirus, got its name. The virus itself looks like a sphere with all these little spikes sticking off of it, which reminded scientists of the corona around the sun. So now we've got another connection to current events. Coronavirus, corona from every star produces some kind of a corona, some kind of a glow, particles escaping into space. All right, so facts about the sun. It is the gravity anchor of the entire solar system. 99% of all the mass in the solar system is in our beloved star, the sun, in the day and the night sky. It's there. We see it at the daytime, but obviously it's still there. The world is just turned around, so it's on the other side. 99% of the mass means all the planets, all the asteroids, comets, every little thing, every moon, every particle of space dust that happens to still be floating nearby, held in stable orbits around our sun, gravity's anchor. Very cool stuff. It is considered a main sequence star. And in chapter 3, we'll talk about what does that even mean. But the type of star, this will be handy to know, is a G-type star, a G2 specifically. But it is on the main sequence. It's basically an average star, middle age, halfway through its life. It's doing just fine. It's healthy. It has good days and bad days. Kind of like, just like an old guy like me, middle-aged, average, normal star, and it's very stable, and frankly that helps life on Earth be sustained and nurtured and not wiped out. So we're glad that its main sequence, average normal star, lives about 10 billion years, and it's about 4.6-ish billion years through that life cycle. When it hits 9 billion, it starts to change. By the time it hits 10 billion, it is completely something different. Again, we'll cover that future, but for now, it's doing just fine. It peaks in the yellow part of the spectrum. Now, the sun produces all the colors of light. Someone may say, oh, our sun is a yellow star. That doesn't mean it only sheds yellow light. That just means the light in all the wavelengths from red, orange, yellow, green, blue, violet, Roy G. Biv, right? Across the whole rainbow, its strongest emanation of color is in the yellow part of that spectrum. You know this because if you hold up a white piece of paper, obviously it's going to show white just fine, not just yellow. Imagine if the sun only shined yellow. I'm going to steal this from Neil deGrasse Tyson. If the sun only shined yellow light, what color would every snow field everywhere in the world be? It would all be yellow snow. No. All the light is there, but our eyes perceive the strongest part of the rainbow in the yellow bit of the spectrum. That's where it peaks, where its strongest emanation. It has layers to it. The earth has layers, the sun has layers. Onions have layers, ogres have layers, right? Right. So the sun has, from the surface, it has its photosphere and its coronasphere. It's got the actual surface of the sun. It's got a place where magnetic and energetic convection takes place. And then it's got its core where the most tremendous pressure and temperatures approaching 1,000,000 degrees are reached, and that's where fusion takes place. So the sun has its own layers as well. And then it's got the beautiful eruptions and solar storms on the surface, and it's just dynamic and dramatic. And don't get close to that thing. Anything that gets too close to the sun will burn up and melt and fritter apart into molecules. I don't care what it's made of. Nothing can withstand being right up against the sun. It's impossible that we know of. All right. That is a lot of information on the sun in a short amount of time. So you've got this part of the video to refer to. You've got all your sources on page 4. When it comes time to build those pages on the sun, you've got some solid information. If you want to credit something from this lesson video, Mr. Sandrock's lecture is a solid reference in the bottom. So you don't have to re-look up things that I tell you. You can pretty much count that I've done my research. All right. So that's the sun. Let's move on to the other big light in the night sky. The biggest in the night sky, our beloved moon. Take a look at this animation. It shows that the moon is indeed beautifully spherical. Okay. And you see the different phases of the moon in this animation, from full moon to half of its illumination. We call that a first quarter or third quarter moon, depending on which half, which side is illuminated, and where it is in the cycle. Then, when it turns completely dark, we have a new moon. And that just means the Earth and the sun are aligned with the moon in such a way that the sun's light either reflects the entire surface towards us, or it's shining on the other side and we only see the shadowy bit of the moon, and it appears dark in the night sky. It looks like there's no moon at all. That's a new moon. Okay. Take a look at the features on the surface. You see dark splotches. Sometimes people see a face, the man in the moon, right? The dark splotches are ancient lava fields. And even as recently as 150 years ago, people were thinking, wow, those look like seas and huge lakes, or at least dried out lake beds. They must be seas or lakes. Let's call them mare, which is Latin for seas. Not quite oceans, but seas for sure. And that gave rise to the idea, well, if the moon has seas, what if it has an atmosphere? What if somehow there's people living on the moon? And for a long time in 1800s America, that was a very popular idea. People would go to their religious leaders and say, what have you heard about this idea of people on the moon? And they would confirm, yes, indeed, there are people living on the moon. They're more handsome than we are, and I hope we can meet them someday. They're very good-looking people. They're wonderfully, delightfully charismatic, and I hope to meet them someday. They didn't know what they were talking about. They were wildly guessing, and of course, they were dramatically wrong. For all the reasons you can imagine, it is literally impossible for life forms such as us to simply walk freely on the surface of the moon without really serious levels of protection. There's no air, there's no oxygen on the moon, nothing grows on the moon, there's no pressure. It is indeed a full vacuum. So anything trying to just stand, you know, free on the surface of the moon would perish very quickly, and it would not be pretty. So there's the moon. Have we been to the moon? Oh, yeah, we've been there. Apollo 11, 12, 14, 15, 16, 17, whole bunch of missions, flybys before that, and then all those missions putting people wandering around on the moon, driving their little lunar rovers, bringing back samples so we could learn what it's made of and how it got started. And that helped us discover some pretty amazing things. More to follow in a different lesson. Let's talk about the facts that we know about our moon today. It's much smaller than Earth, and because it is less massive, it has a weaker force of gravity, 1/6 of the gravity that we're used to here on the Earth. So if you have, let's say you're 150 pounds, I'm picking a random number in the air, a 150-pound person divided by take 1/6 of that, 150 divided by 6, boom. On the moon, you would weigh, what is that, 30 some odd pounds? Hang on. I picked all right, 120 would be 20 pounds, 150. So like you'd be really light, like 25, 30 pounds. That's how much you would weigh on the moon if you were in the 120 to 150 range. You'd be bouncing along. You could take a flying leap and you'd have lots of time to think about it before you came back down to land on the moon's surface. Pretty cool. Now, our moon is unique and wonderful for the rocky planets near the sun. Mercury, Venus, Earth, and Mars. None of the others have a large, close moon nearby. And some of you who know your stuff are like, hold on, Mr. Sandrock, hold on. Mars has 2 moons. true, but we really strongly believe those to be captured asteroids. So they were just asteroids in the asteroid belt, wandered a little too close to Mars, and Mars, with its pretty good gravity, passing nearby those said, "You're mine and you're mine." And Phobos and Deimos are like, "Okay, I guess I'm going along for the ride." And now they still orbit, neatly balanced, stable orbit around Mars to this day. Now, our moon, it's an anomaly. Astronomers noticed this and they started hypothesizing. They started making educated guesses as to how our moon formed. Combine that with the rocks that the astronauts brought back from the moon, and we start seeing a clear picture that the moon did not form alongside the Earth originally. Something happened. Something big. I'm talking Mars size big. Smashed into the young Earth, cracked the Earth open, rang the whole planet like a bell, destroyed the other object, they nicknamed that Theia, and bits and pieces of it orbited for a long time until they settled down into a moon going around our Earth. And now we have a moon, a big spherical moon, and we see it every night. So it was born in violence. And after that impact, it was really close to Earth. Man, the moon filled half the night sky. It was so close, some astronomers have suggested the tides that would have been produced with the ocean rising and falling would have been 1,000 miles up, down, washing inland for 1,000 miles and receding back 1,000 miles. But over time, the moon, due to tidal forces, was pushed away from the Earth, and it gets an inch or two further away every year forever. So eventually, it'll be so far away, it'll be tiny in the night sky. But we don't have to worry about that for a very long time, obviously. Now, it has highlands, it has hillsides, it has craters, it has the mare I mentioned before, these big flat areas that were once thought to be seas. But take a look at this photograph in front of you. That's a really good high-res image of one of the landing sites. You could see the little footsteps of the astronauts walking around. You could see the tire treads of the little dune buggies, the Mars rovers that they had, and that they were riding around on as they were exploring their surroundings before they boarded their return craft and made it safely back to Earth. So check that out. You're going to find in the YouTube links below a couple more links to look at to learn more about the moon, and I'll add another one about the sun. All right, there we go. Interesting things about the moon. How are you going to capture this in your book? Turn to page 6 and 7, and I invite you to take a look. Now, what you see in front of you here is one example of how your book, page 6 and 7, might look. You can see on this example, on one side, I've put the picture of the sun and the moon, and on the other side are the facts and figures about the moon. You've got some facts, some data, some numbers, and please include sentences about each one. The sun is more than just its numbers. The moon is more than just its facts and figures. Write something about the sun, something you research, something you know. Doesn't matter to me. But if you're going to take ideas from somewhere else, quote them at the bottom. I mean, there we go. Over there on the other side, look at the bottom of page 7. Okay. At the bottom of page 7, sources, spacefacts.com/the sun, spacefacts.com/the moon. These sources you see in this video, may I suggest those are excellent sources for answering all the things that are up there above where it says the sun and the moon, and you have to quote them down below where you give credit where it's due. Now, since this is a layout I've suggested, are you stuck to this kind of a layout? No. Let me show you what another student has done in the past. Check this out. Totally different layout. And it's still the same basic information. That's page 6 still. Okay, look down below. Page 6. And then over there, way over there, page 7. Okay. And we've got the sun, top of one side, the moon, top of the other side, facts, sentences, and still a sketch of both. Okay, we've got our picture of the sun, big and dramatic, and then way up there in the corner, there's the moon. Please include images of both, facts about both, 2 to 3 sentences about both. They deserve it. We know so much about them. Give them their due. Give them a little bit of your effort. Make it something you're proud of, my friends. Okay, so there's the sun and the moon. And that concludes our lecture for today. I told you I'd keep it brief, and go ahead and get started. Build something you're proud of, and follow the guidance on Canvas on how to submit your work when you're done through page 17 and you're ready to turn in the first half of chapter 1. Reach out to me if you have questions in Canvas. I'm reachable. And on Friday, I'm dedicated all day long. I'm checking my emails, making sure that that anything that anyone asks me, I can respond very quickly. All right. Okay. Any questions? Reach out to me. Build something amazing. Build something you're proud of. Make sure every page is filled. Include your sources. Be creative and have a ton of fun.